Hello everyone, it's Red Saber here from Saber C++, and today we're going to be learning about these RGB LED strips. In this video, I'm just going to be covering the basics of getting them wired up and doing a very simple program, which you can see right here. If you want more complex behavior, check out my more advanced RGB LED strip tutorial in the description after you finish this one. If you want to follow along, I've put a few links in the description so you can get what you need to create this. Let's get started. This is the RGB LED strip I'm going to be using. Yours may look a little different, but that's okay, as almost every company that makes these uses the same or a similar type of RGB LEDs so that we can control them in the exact same way. As you can see, our LEDs are spaced out along the strip. Mine have, I believe, 60 LEDs per meter, and I think the strip is 5 meters long. As you can see, we also have these copper pads placed at intervals. Now we can cut it on any of these copper pads to shorten it down to the length we want. We could also connect another strip on the end using this plug, or we could cut it at the last one of these copper pads and solder it onto another strip. But for now, I'll just use it as the length it is. The wiring for this is actually quite simple. I'll start by connecting a red wire from this thing's red wire to the 5-volt port on the Arduino. Then I'll connect this black wire from the white wire on here, which is the ground wire, to one of the ground pins on the Arduino. The last thing I'll do is connect a green wire from the middle wire on the LED strip, which is the data wire, to one of the digital ports on the Arduino. In this case, port 2. For this type of RGB LED strip, we only need one data wire and it's connected to a digital port because we'll actually be using time-based signals to communicate between the Arduino and the controllers on each of these LEDs. Each of these LEDs has its own controller, so we can set each of them to a different color if we want to, and make all sorts of cool lights and patterns, which we'll get into later. That's all of the wiring, so let's hop over to the computer and get coding. Communicating with the controllers built into the LEDs is pretty complicated, but thankfully others have already done the hard work for us. So we can just go to this page, which I've linked to in the description, click on the latest version, which is at the top, and then download the source code as a zip file. In the Arduino IDE, we'll go to Sketch, Include Library, and Add.zip library. From there, we can navigate to our Downloads folder and select the Fast LED library that we just downloaded. If it asks if you want to overwrite it, go ahead and click Yes, as this is the latest version. Once we've installed it, we can go to Sketch, Include Library, and then scroll down to the Fast LED library. If we click on that, it'll add this line up here, which says #include fastled.h. Now that we have access to all of that code we just downloaded, we can start setting up our LED strip. First, we'll need to define a few values about our LED strip. I'll start by defining the pin that the LEDs are connected to. In this case, 2. We also need to define how many LEDs we'll be using. In my case, I have a 5-meter strip with 60 LEDs at each meter, which means that I have 300 LEDs overall. Most likely yours is the same, but if not, you can simply adjust this to whatever you need to. Next, we'll set the brightness of the LED strips somewhere between 0 and 64. So I'll declare a variable called brightness, and I'll set mine to 64, as I like them to be as bright as possible. Now, I mentioned before that these LED strips are manufactured with the same or similar LEDs, and that's true. So we'll need to define which type of LEDs we have on our strip. If you got the ones from my link in the description, then it'll be WS2812. If you didn't, you'll just need to check out the description of the item you got and see what type it is. It might be WS2812 or WS2812B or something like that. If you need any help, you can leave a comment below or ask in our Discord community, which I've linked to in the description. The last thing we need to define is the color order, which is the order in which the LEDs are actually wired. All of the LED strips I've used have been RGB, so I'll use that, but if you're having trouble with this, just reach out. We'll also need an array that will hold all of the color values for each of the LEDs, so that we can set the first item in the array to red, and the first LED will become red. And if we set the second item in the array to blue, the second LED will become blue, and so on. The type will be CRGB, and the name will be LEDs. The number of LEDs, which we'll put inside the brackets, is the numLEDs variable that we just defined. Now, in the setup function, we'll need to tell the Fast LED library to add an LED strip with all of the information that we just defined above. So we'll type fastled.addLEDs. We'll need to open this first part with a left chevron or less than symbol. And in it, we'll put the LED type, the LED pin, and the color order. Then we'll close it with a right chevron or greater than symbol and open up some parentheses. In here, we'll put the LEDs array, which we just created, and the number of LEDs. Now that we've set up our LED strip, let's go ahead and set the brightness using fastLED.setBrightness, and putting in the brightness value that we declared above. Our LEDs are now set up, but we haven't actually set them to any color yet, so let's do that in the loop function. I'll start by creating a for loop with an integer called LED_index, which will start out as 0, and will continue for as long as LED_index is less than the number of LEDs, which we defined up above. Each time the loop function runs, we'll increment LED_index by 1. Inside of the loop function, we'll get the LED at LED_index from our LEDs array, and we'll set it to a new color. Our color object will be of type RGB, as we defined up above here, and we create it using 3 integers, one that represents the amount of red, one that represents the amount of green, and one that represents the amount of blue. These values go from 0 to 255, so if we set them all to 0, that would be black or off, and if we set them all to 255, that's white. So in this loop, we're going through each LED from the first, which is at position 0, all the way up to the last, which is just under num LEDs, and each one we're setting to white. We also need to tell the fastLED library to go ahead and show the values that we just assigned to our LEDs, which we can do using the fastLED.show function. Alright, let's make sure our board is connected and hit the upload button. Speaking of buttons, if this video has been helpful to you so far, please hit the like button. As you can see, now all of our LEDs are lit up white. Let's try changing the colors a few times in our code to make it more interesting. Let's change this code in the loop function so that instead of setting all the LEDs to white, it sets all of them to red. Remember that it goes red, green, blue. So we'll leave the red at 255 and set the green and the blue to 0. So the red LED will be fully on and the other 2 LEDs will be completely off. Then we'll add a delay function for 1 second and then set all of the LEDs to another color. I'll go ahead and copy all of the code we've added so far and simply paste it in. This time I'll set the color to purple, which is full red, no green, and full blue. I'll copy everything once more, and this time I'll set the color to a nice light blue-green, which will be no red, full green, and full blue. Let's try it out. As you can see, we now turn each color on for 1 second, and then move on to the next color. There's a lot more we can do with these LED strips. If you're interested in seeing how we can change the color correction settings, change each LED to a different color, and do a lot more interesting combinations, check out my next video on LED strips, which I'll link to in the description. Thanks for watching.